Alright, this is going to be Saxon Math Course 3, Lesson 94, Graphing Pairs of Inequalities on a Number Line. To start off with our lesson, we've got some vocabulary. Now, these are words that you see every day, and, or. And is going to be similar to an intersection of a set. It's the portion of a graph that is covered by both inequalities when we're talking about a problem where we're given two inequalities. So we might have, for example, x is greater than negative 3 and x is less than 3. That's how we would read this. You could also say negative 3 is less than x and x is less than 3. What this means is if you graphed each of these separately, the answer to this whole problem would be the area of the graph that is covered by both. Or is similar to the union of sets. Remember when we talked about the union of sets, we said that the union was anything that was in one set or the other or in both. If you see an or function, if you see x is less than or equal to negative 3 or x is greater than or equal to 3, then you're going to graph both of the inequalities on the same number line. So we've already graphed inequalities on a number line already. An important thing to note, if we have a less than, such as this, versus a less than or equal to over here, a less than has an open dot on its graph. A less than or equal to will have a closed dot on its graph. The reason for that is the graphs of an inequality are the numbers which you could plug in for x. It wouldn't make sense to plug in 3 for x and say that 3 is less than 3. It's not. It's equal to 3. If less than or equal to, greater than or equal to is your problem, then you can have a closed dot representing the boundary of the inequality. If we're having one inequality where it represents multiple things, you might have more than one dot. You might have an open dot and a closed dot. You might have an open dot and an open dot, which is what we would see here, or a closed dot and a closed dot, which is what we see here. Now, that's our vocabulary and background for today. We're going to go in on example 1 next. Now, example 1 says, use a number line and an inequality expression to describe the length of one side of a triangle is greater than 2 and less than 8. Now, an important thing to note, it just says greater than, it just says less than. It does not say or equal to in either of them. So I'm going to make a little note here that just says not equal. And then let's write our inequality. Now in the middle we're going to have our S for side S. Now we know that the side S is greater than 2 and less than 8. So greater than 2 means that S is going to be greater than, meaning the big part of the inequality is going towards the S, 2. And less than, meaning the small part of the inequality is going towards the S, 8. Important to note here, the small part points to the one which is less than, the large part points to the one which is greater than. Now, since neither of these are equal to, both of them will be an open dot. We're going to have an open dot on 8. We're going to have an open dot on 2. And when we're graphing this, if I have numbers which are greater than 2, it'd be to the right. If I had numbers which are less than 8, it'd be to the left. So the graph of this inequality is going to include everything in between 2 and 8, because these are the numbers which are both greater than 2 and and less than 8. Make sure that you pay attention to that and. If it was or, we would need to continue the lines. But numbers over here, they're less than 8, but are they greater than 2? No, they're not. The numbers on this side, they are greater than 2, but are they less than 8? Is something like 9 less than 8? No. So we're not going to have a graph over here. We have open dots on our graph. We have open dots because they're not equal to. Moving on to example 2 in 3, 2, 1. Now, example 2 says graph -1 is less than or equal to x. X is less than 5. Now, to do that, I'm going to break this up into the left side, the right side, and the whole thing. So, the left-hand side says that -1 is less than or equal to x. Well, this is less than or equal to. It's got that line. It's got that thing that looks like an equal sign in it. So that means I'm going to have a closed dot on -1. So I'm going to have a closed dot on -1. And if -1 is less than x, x is greater than or equal to -1. Remember, greater than starts with that R sound, so it's going to the right. So we're going to the right. Also, we can remember that the numbers over here are bigger than 0. They're bigger than -1. We got our 2's, our 3's, our 4's. All those numbers. So we would have our line go to the right. And it can continue even further. It's going to go on forever, right? Now, our right-hand side is x is less than 5. Now, this less than does not have an equal to, so we're not doing a closed dot. We're going to do an open dot. We're going to do an open dot on 5. Less than, remember, always goes to the left. And now we have our left side, our right side. We can do the whole thing. When we do the whole thing, the first thing we copy is the dots. We're going to copy the dots. There's a dot at -1, and it's a closed dot. There's a dot at 5, and it's open. And now we look, where do they overlap? Where do they intersect? Where are both lines colored? They're both covered between -1 and 5. Between -1 and 5, they both have a big line there. So the answer here looks like this. This is our final answer, where we have a closed dot at -1 because x is greater than or equal to -1. Open dot at 5 because x is less than 5. And we're going to have a line connecting them. Now, moving on to example 3. Graph this pair of inequalities. Now, this says t is less than 40 or t is greater than 100. So, I'm going to do the same thing I did up here, where we have our left one, our right one, and the whole thing. Now, the left-hand inequality is t is less than 40. So we're going to put an open dot on 40. It is less than, so it's going to the left. Our right-hand one is t is greater than 100. So I'm going to put an open dot on 100, and I'm going to move to the right. Now, the whole thing is an OR statement, meaning we're doing the similar thing to the union. which means we look, is it on this graph? Is it on this graph? Or is it on both graphs? Any of those things are true, it's on here. So I'm going to copy from the first side down here, an open dot on 40 with a line going to the left. I'm going to copy down from the 100, an open dot there, a line going to the right, and that is our final answer for example 3. Now, just in case anyone needs this, I'm going to write this out here. If you don't feel like you need this, that's okay. You don't need to copy this into your notes if you don't want it. If you think that you're going to forget, copy this down. Open or closed. Less than, greater than, open dot. Less than or equal to, greater than or equal to, is a closed dot. Other than that, it's just remembering and or, which was in our vocab, and whether or not you should have an open and closed dot. Remember that we also probably should have our left or right. If we have less than or less than and equal to, we go to the left. If we have a greater than or equal to, we're going to the right. Remember, this is always from the view of the x towards the other number. If there is a number to the right of the x instead of, or if the x's swap places, usually the number is to the right of the x, like up here. If it's in this format, you follow these rules. If, for example, here, we have the -1, it says -1 is less than or equal to x. Less than or equal to x means that x is greater than or equal to it. So remember, you're always focusing from the perspective of x. Alright, that's going to be the lesson for today. Stay safe, wash your hands, do your homework, and have a wonderful week.